Hello, this is Suhas Kamath and I'll be telling you about chemistry. 2012, no, 2013 June, sorry. And we're gonna do paper 6 to 2. So let's increase this. And there's nothing interesting here. Let's go to the next page. Student extracted the colors present in some leaves using the apparatus below. Complete the boxes to identify the pieces of apparatus used. So we can write by using this tool here. Yeah. So write with the Lovenol style, and the color will be blue. So this is a pestle. And this will be a filter funnel. Yes, filter funnel. Label the arrows to indicate the solvents. The solvents will be this one, the labeled arrow here. The solution of colors. This will be the labeled arrow number 2. Chromatography was Chromatography was used to separate the colors. The chromatogram obtained is shown. On the diagram, label the solvent front. This line at the top is the solvent front. How many colors were present? 1, 2, 3. So the answer here is 3. A student investigated the reaction. Let me use a different color, sorry. The student investigated the reaction of methane, CH4, and copper dioxide. She put methane gas over hot copper to oxide using the apparatus shown. The solid changed color to red-brown and drops of liquid condensed in the cold part of the tube. What was the original color of the solid? It would be black. Suggest the identity of the red-brown solid. So CH4 plus CuO will produce, let's write the equation here, CH4 plus CuO to produce H2 plus H2O. So and then let's not do this because I have no idea on how to do this. That's okay. Suggest the identity of the red-brown solid. The red-brown solid can be copper hydroxide. I know it actually yet, but I wanted to prove it to you, but I was not able to do it. So hydroxide. The drops of liquid is of course water. Suggest a physical test. Measure its melting and boiling points. results. It should be, it will be 100 degrees Celsius. Let's turn over the page and then what's happening? Oh yeah. The student investigated the reaction between solutions of deep purpose aqueous potassium manganate 7 and two different colorless solutions B and C. So let's just take a minute to understand. Read again. The solutions of an acidic solution, sodium salt and a sodium salt. Two experiments were carried out. A burette filled with solution of potassium manganate 7 to the 0.0 cm cubic mark. Using a measuring cylinder, 25 cm cubic of potassium solution B was poured into the conical flask. The potassium manganate 7 was added slowly into the flask and shaken to mix thoroughly. Addition of the solution was continued until there was a permanent pink color in the contents of the flask. So this is nothing but a kind of titration. Use the burette diagram to record the volume in the table of results and complete the table. So the final reading here has to be around 26.0. And the initial reading must be 0.0, and the difference must be, of course, as you can calculate in a second or so, 26.0. So experiment 1 was repeated using solution C instead of solution B. Use the burette diagrams to record the volumes in the table and complete the table. So the final reading is, wait a minute, let me just reduce my handwriting, reduce my size so that, yes, it will fit in. So the final reading is 42 and the initial reading is 19. And the difference is, even though you can calculate it by a scientific calculator, I like to calculate it just like that. It's 13. So what color change was observed in the contents of the flask when potassium manganate 7 solution was added to the flask in experiment 1? From deep purple, from purple, wait a minute, so it's better in this way.
It's 12 o'clock.
Thank you. From purple to colorless, from purple to pink. Was an indicator, no, because there will be a color change anyway, so it'll not go until that if you write in normal handwriting. I'm writing in extra large handwriting, yeah, so there'll be somewhere there. In which experiment was the greater volume of potassium manganate used? You can just look at the results and you can explain yourself. 13, 26. Of course, you know which one is used more in experiment 1. Experiment 1. Compare the volumes of potassium manganate 7 solution used in experiments 1 and 2. Experiment 1 is twice than experiment 2. So just an explanation for the difference of volumes in. So they use solution B first. So let's say solution B is more concentrated than solution C. It's quite easy. Or you could say twice as concentrated. Twice as concentrated as solution C. If experiment 2 were repeated using 12.5 centimeter cubic of solution C, what volume of potassium manganate 7 solution would be used? So here you must see what has happened before. So solution C, experiment 2. Solution C, how much did they use originally? So they used 25, now they are using 12.5. So the volume used will be half as well. So in place of 13, it will be 6.5. 6.5. Wait. In place of 13, it will be 6.5. So write it down here. 6.5 centimeter cubic. Should write cubic here? Cubic. Because the volume of solution C is halved, the volume of potassium manganate 7 potassium manganate 7 solution potassium manganate solution is also a redox reaction occurs when potassium manganate 7 reacts with solution B and C. So they're not asking how the redox reaction happens, but they are asking the term what is redox reaction. A redox reaction is a reaction in which oxidation and reduction occur together. Advantage. So whenever we look at the textbook, they say that why their measuring cylinder is inaccurate, then why is it still used? Because the advantage is easy and quick to use. The disadvantage is not very accurate. So a mixture of two solids R and S is analyzed. The solid R was the water-soluble aluminum sulfates Al2SO4 and solid S was an insoluble salt. The text on the mixture and some of the observations are in the following table. Complete the observations in the table. Distilled water was added to the mixture in a boiling tube. The boiling tube was shaken and the contents of the boiling tube filtered, keeping the filtrate and residue for the following tests. The filtrate was divided into 5 test tubes. So what has happened here? They mixed in water, so all the aluminum sulfate got inside the water and solid S was left over. So now, what's next? So they filtered it, so solid S and solid R are separated. Now the solid R solution, so solution R is split into 5 portions. Appearance can be colorless. Let's change our color once again, because it's good to be colorful. Oh, we can't see this color, so better change our color again to this color. Yes, this color is perfectly visible. Sorry for the mishap. Drops of aqueous sodium hydroxide were added to the second portion of the solution and the test tube shaken. Excess sodium hydroxide was then added to the test tube. So, when aluminium is present and sodium hydroxide is added, a white precipitate will form. It will dissolve on adding excess of sodium hydroxide. So white precipitate forms. White precipitate forms. It does not dissolve when an excess is added. Wait a minute. When an excess is. Don't worry, it'll not go until that length. It's just because I'm using an excess of handwriting, you know. C, aluminium. So aqueous ammonia is added to the third portion, dropwise and then in excess. So when ammonia is added, a white precipitate forms again, but it will not dissolve. An insoluble white precipitate forms. Dilute nitric acid was added to the fourth portion of the solution, followed by aqueous silver nitrate. By this, you can test for halides. So we don't really have any halides here. So you just write no reaction. Action. Dilute nitric acid was added to the fifth portion of the solution and then aqueous barium nitrate. So it can test for sulfate, SO4, 2 minus ions, SO4, we have got them. So a white precipitate forms. So white precipitate forms. Now, if you see that, if you think that I used more than an hour, which is the limit for this test paper, don't worry, because it will always take a longer time for me to type than to write. You understand? So don't get scared. So dilute hydrochloric acid was added to the residue. See the word residue? The gas given off was tested. Lime water turned milky. There's only one gas that can turn lime water milky, and it is carbon dioxide. So why not just write it down? Carbon dioxide. Or you can write the symbol also CO2. What conclusions can you draw about solid S? So about solid S, so excess sodium hydroxide is added. So when sodium hydroxide is added, white precipitate forms if aluminium or zinc ions are zinc or calcium ions are present. So it does not dissolve. It is insoluble. So it can't be aluminium because it's soluble. It cannot be zinc because it's soluble. It has to be calcium. It is calcium carbonate CaCO3 limestone. Is right. It is calcium carbonate. Or just write CaCO3. It is CaCO3. So let's go to number 5 and let's change our color again to black. A student investigated the temperature changes when dilute nitric acid neutralized acidic alkaline potassium hydroxide. The instructions followed are listed below. The solutions were left at room temperature for 1 hour. Using a measuring cylinder, 20 centimeter cubic of aqueous potassium hydroxide was poured into a polystyrene cup and its temperature is measured. From a burette, 5.0 centimeter cubic of nitric acid was added to the cup. The highest temperature reached by the mixture was measured. A further 5.0 centimeter cubic of nitric acid was added to the mixture and the highest temperature measured. So just understand it, read it once again. Okay, so you'll have to do this. So a total of 30 centimeter cubic were added. So this one, as you can see clearly, if you cannot see clearly, magnify it if you're doing on a computer. If you're not doing it on a computer, then you can just move your eyes closer to your paper. So 23. This is a very easy thing. And if you don't score marks in here, then you cannot score marks anywhere. Even my little kid brother can do it. Why can't you? You see, when talking to you, I finished more than half of the volumes. Now on the volume, the temperatures. Now the temperature is not increasing. By the way, it's decreasing because it indicates that the reaction has finished when 15 centimeter cubic was added. I can bet my fingernails that. I can bet my fingers that they'll ask you to draw a graph on the next page. You don't believe me? See? Plot the results on the grid. Draw 2 intersecting straight lines to the point. So, since I cannot do this on my computer, it's better if you can do it. It's quite simple. You have learned about it, all of it in math, I'm sure. From your graph, work out the volume of nitric acid needed to completely neutralize the 20 centimeter cubic of aqueous potassium hydroxide using an arrow. Show clearly on the grid this neutralization point. Needed to completely neutralize. Don't worry. So you should see when the reaction stops. So it's 15 centimeter cubic, as I showed you already. 15 centimeter cubic. What was the room temperature? So the temperature went 0.0, so it's 23 degrees Celsius. (23 degrees Celsius). Why was a polystyrene cup used instead of a glass beaker? Right, polystyrene. Wait a minute. Wait a minute. Oh shit. My computer's gone kind of mad. Polystyrene cups do not lose heat. What does the temperature increase then decrease? Increase is right because the reaction is an exothermic reaction. Then decrease. Because the reaction has finished and the mixture is cooling down. What type of chemical reaction is this? Exothermic. Two metals A and B each react with dilute sulfuric acid to produce hydrogen. You can plan an investigation to show which metal A or B is the more reactive metal. You may include a diagram in your answer. So let's begin here. The different color because it's gonna get exciting now, very exciting. So I'm gonna use orange, the heat color. So powdered metal A is weighed. The mass is recorded and the metal is then added to the sulfuric acid. My computer is, I guess, an American style now, so it does not accept SULF. It accepts SULPF or something, sulfuric acid. And the metal is then added to the. You see now the red line went, so my computer probably recognized it's correct. To this sulfuric acid. The volume of gas released is measured by using a gas syringe. Remember that syringe begins with S, not C. C is wrong. The experiment measured by using a gas syringe. Is measured and recorded. Measured and recorded by using a gas syringe. 2. The experiment is repeated by using powdered metal A of the same mass. So the mass is recorded to the sulfuric acid. Sorry, I missed some words out here. Sorry. Uric acid of known volume and concentration. The experiment is repeated by using same mass and is added to the same volume of sulfuric acid metal A. Metal A. So you would stop here, and nothing of this is needed. The metal which produced a higher amount of gas, not powdered metal A, powdered metal B, a higher amount of gas is in a shorter amount of time is the of time is the more reactive metal.